In these next two lessons, we're going to introduce and explore one of the economist's favorite ideas, comparative advantage. And we're going to show how two people with differing abilities can cooperate to increase their wealth. We're going to be using the tool that we developed in the last lecture, the Production Possibilities Frontier. And we're going to first derive the Production Possibilities Frontier for a cleaning service run by Bernie. In the next lesson, we'll be introducing a potential cleaning partner for Bernie and show how cooperation can increase the wealth of both cleaners. But first, let's look at Bernie. Bernie has a service that provides two cleaning chores. Bernie scrubs rooms and Bernie sweeps rooms. The first thing that we want to do is explore Bernie's technology. That is, what is Bernie able to do? Well, let's look. Bernie takes 20 minutes to scrub one room. Bernie takes 10 minutes to sweep one room. In economics, we call these numbers the unit labor requirements, how much time it takes for Bernie to perform each of these tasks. And the unit labor requirements describe Bernie's productivity. Notice that Bernie can sweep faster than he can scrub. So 20 minutes to scrub or 10 minutes to sweep. Now let's suppose that Bernie is going to work for 1 hour. How much can Bernie accomplish? Well, if he devotes an hour to scrubbing, then we can find out how many rooms he scrubs by dividing 1 hour, or 60 minutes, by the time that it takes Bernie to scrub one room. So 60 minutes divided by 20 minutes is equal to 3 rooms scrubbed in 1 hour. If Bernie devotes 1 hour to sweeping, on the other hand, divide 60 minutes by 10 minutes per room swept, and you find that Bernie can sweep 6 rooms in 1 hour. So we'll use these numbers then to represent Bernie's productivity. That is, if Bernie spends all of his time scrubbing, in an hour he can scrub 3 rooms. If Bernie spends an hour sweeping, he can sweep 6 rooms. Now, of course, if Bernie has an hour to work, he needn't do all sweeping or all scrubbing. In fact, he can do any combination of the two. So what we'll do now is derive a production possibility schedule for Bernie by looking at different combinations of sweeping and scrubbing that are possible for Bernie in 1 hour. Remember, Bernie can spend 10 minutes sweeping or 20 minutes scrubbing and divide up his hour any way he likes. Well, let's look at some numbers that work for Bernie. And here we have a production possibility schedule, much like the one that we looked at last time for rice and wheat. Bernie can spend an hour scrubbing and scrub 3 rooms. That leaves no time for sweeping, so he sweeps 0 rooms. If Bernie decides that he wants to sweep 1 room, that's going to take 10 minutes. Subtract 10 minutes from 60 minutes to leave 50 minutes. Bernie has 50 minutes now to spend scrubbing, and if you divide 50 minutes by 20 minutes per room scrubbed, you find that Bernie has time to scrub 2.5 rooms. If Bernie wants to sweep 2 rooms, however, that's going to take 2 times 10, or 20, leaving only 40 minutes for scrubbing so that he can scrub a total of 2 rooms. And so forth. If he wants to sweep 3 rooms, that leaves him time to scrub 1.5. If he wants to sweep 5 rooms, that leaves him time to scrub only half a room. And if he spends all of his time sweeping, so that he spends no time scrubbing, he can sweep a total of 6 rooms. This is the production possibility schedule for Bernie. Notice, as we look at these numbers, we are already getting a taste of Bernie's opportunity cost. Every room that Bernie sweeps causes him to give up 1/2 of a room scrubbed. The opportunity cost for Bernie of sweeping 1 room is 1/2 of a room that he doesn't scrub. Well, the next logical step is to take the information from the production possibilities schedule and represent it in a graph. Here's how that would work. I'll move these numbers over to the board so that you have them for reference, and I'll put up some axes that we can use to draw a production possibilities curve for Bernie's business. Let's put sweeping up here on the vertical axis, and let's put scrubbing on the horizontal axis. So here's sweeping, and here's scrubbing. Now let's plot numbers from Bernie's production possibilities schedule into this diagram. And we see that let's see here, 1, 2, 3, 4, 5, 6 rooms is the maximum that he can sweep, and 1, 2, 3 is the maximum that he can scrub. So it looks like my chart here is going to work. I'm going to calibrate my axes a little bit differently just for the sake of making things nice and neat. I'm going to let each of these hash marks represent 2 rooms swept. So here's 1 room, 2, 3, 4, 5, 6. And I'm going to let each of the hash marks down here on the bottom represent 1 room scrubbed. So here's 1, 2, 3, 4, and so forth. I could go ahead and put the numbers in to calibrate the axis. So let me do that just to make things nice and neat. Here's 2, 4, 6, 8, and so forth. And down here we have 1, 2, 4, 5, 6, 8, and so on. Now let's put in the points from the schedule into the diagram so that we can plot the production possibilities curve. Let's start here with, if we scrub 3 rooms, then we can sweep 0. So go to 3 rooms scrubbed and 0 rooms swept, and we get this dot right here on the production possibility frontier. 3 scrubbed, 0 swept. If we sweep 1 room, then we're going to only be able to scrub 2.5 rooms, so we're going to get a point like this one right here. If we decide to sweep 2 rooms, then we're going to be able to scrub 2 rooms, so that gives us a point like this one, and so forth. Just keep plotting the points. If we are going to scrub 1.5 rooms, that leaves us time to sweep 3. And if we scrub 1, that leaves us time to sweep 4. 1/2 leaves us time to sweep 5. And if we don't do any scrubbing at all, we can sweep 6 rooms. Well, there you have it. There's the production possibilities frontier for Bernie. Bernie can sweep anywhere from 0 to 6 rooms. He can scrub anywhere from 0 to 3 rooms. And if he divides his time, he can achieve any combination that's on this line. Let's now imagine that Bernie can divide his time even more finely between sweeping and scrubbing, and we'll be able to connect those dots and get a straight line. This is what Bernie's production possibilities frontier looks like. Well, let's notice a few things about Bernie's production possibility frontier. First, the vertical intercept represents the maximum number of rooms that Bernie can sweep if he spends a whole hour sweeping. The horizontal intercept represents the maximum number of rooms that Bernie can scrub if he spends all of his time scrubbing. The downward slope reminds us of scarcity. Bernie's time is scarce. If he wants to scrub more rooms, he has to give up rooms swept. There are points outside the production possibility frontier representing Bernie's limitations. He only has an hour, so he couldn't, say, sweep 6 rooms and scrub 6 rooms. That would take too much time. There are also points inside the frontier if Bernie were using his time inefficiently. So the intercepts tell us about the maximum amount of sweeping or scrubbing that Bernie could possibly get from an hour's worth of time. What about the slope of the line? What does that tell us? The slope, as usual, tells us about the opportunity cost of scrubbing measured in terms of sweeping. That is, if Bernie wants to scrub 1 additional room, that is, if we want to increase scrubbing from, say, 2 rooms to 3 rooms, then that is a horizontal movement in this space. That means we would have to reduce the amount of sweeping that Bernie does. That would be a vertical movement in the space. And if we take the amount of sweeping that Bernie gives up to do an extra room's worth of scrubbing, that gives us the opportunity cost of scrubbing the room. So the rise, which in this case would be a change in Bernie's sweeping, a reduction in the amount of sweeping that Bernie is able to do, over the run, which would be the increase in scrubbing, is the slope of the production possibility frontier. In this case, in order to have a change in scrubbing equal to 1 room, we get a change in sweeping equal to -2 rooms. For every room that Bernie scrubs, he gives up 2 rooms that he could have swept. The slope of this line is -2. and it's the opportunity cost of scrubbing for Bernie, measured in terms of the sweeping that he can't do. Of course, this is logical. It takes him 20 minutes to sweep or to scrub a room. It takes him 20 minutes to scrub a room. Divide that by 10 minutes that it takes to sweep a room, and you see that he could be sweeping 2 rooms in the time that it takes him to scrub 1. And that's the slope of this line. The opportunity cost is the slope of the production possibilities frontier. Notice that we have a line here, so we can describe it with an algebraic equation. We can describe it with an algebraic equation. And in this case, the equation for this line is going to be, first of all, we have the variable on the vertical axis. So I can write this sweeping. That's the thing we're going to be describing with our line. Sweeping is going to be equal to, the next thing you do is write down the vertical intercept. 6 rooms swept. This is the maximum number of rooms that Bernie can sweep if he spends a full hour sweeping, minus the slope of the line, which in this case is 2, multiplied by the vertical or the horizontal axis variable. The horizontal axis variable is scrubbing. So here's the formula for the line. Intercept minus slope times x-axis variable. The amount of sweeping that Bernie does is equal to 6 rooms, the maximum that he can sweep, minus 2 times the number of rooms that he scrubs. Because anytime he scrubs a room, that takes 20 minutes, and that's time enough to sweep 2 rooms. So the vertical intercept is the constant in this equation, and the slope, -2, is the opportunity cost of scrubbing measured in terms of sweeping that Bernie isn't able to do. When he scrubs a room, he gives up 2 rooms worth of sweeping. There's the equation for Bernie's production possibilities frontier. Well, it seems kind of arbitrary that we've put sweeping on the vertical axis and scrubbing on the horizontal axis. And it is, in fact, quite arbitrary. We could have just as easily put scrubbing on the vertical axis and sweeping on the horizontal. Well, I'd like to try to make that point clear now by taking the production possibilities frontier and showing you how to convert it into the other way of expressing things, with scrubbing up top and sweeping on the horizontal. Here's what I'm going to do. I'm going to put this line in for my production possibility frontier, and I'm going to secure it with tape. And what I'm about to do is simply transpose the axes. I'm going to just convert this diagram from one with scrubbing on the horizontal to one with scrubbing on the vertical. Bernie still has the same productivity, no matter how we express it. Bernie can still do the same combination of sweeping and scrubbing, but I'm just going to change the way I write it. And it's going to be as easy as picking this graph up and flipping it over so that the scrubbing axis is vertical and the sweeping axis is horizontal. I'll have exactly the same expressions. So let me do that then. I'll pick scrubbing up and put it on the vertical. I'll pick sweeping up and put it on the horizontal, and then I'll flip my diagram over so that the scrubbing information is on the vertical and the sweeping information is on the horizontal. Now notice I've got a bit of a mess here because I still have all the markings that I did for my previous graph. But if you'll bear with me and let me tape my production possibilities curve down to the axis firmly, and if you'll let me clear my pad here so that I get rid of the old writing. And voila, we've got the new production possibilities frontier with sweeping on the horizontal axis and scrubbing on the vertical axis. The vertical intercept is now the maximum amount of scrubbing that Bernie can do if he scrubs for an hour, and as we've seen, that's equal to 3 rooms. The horizontal intercept is the maximum amount of sweeping that Bernie can do if he sweeps for an hour, and as we've seen, that's 6 rooms. The formula for this new equation is going to be given by this expression. Bernie's production possibilities frontier, expressed this way with scrubbing on the vertical and sweeping on the horizontal, has exactly this mathematical expression. 3 is the vertical intercept, or the maximum number of rooms he can scrub in an hour. And negative 1/2 is the opportunity cost. Anytime Bernie sweeps an extra room, that takes 10 minutes. 10 minutes divided by 20 minutes, the amount of time that it takes to scrub a room, gives us 1/2. Anytime Bernie sweeps a room, he's giving up 1/2 of a scrubbed room, because it takes half as long to sweep a room as it does to scrub the room. So there you have it, Bernie's production possibilities frontier. Scrubbing is equal to 3 rooms max minus 1/2 the opportunity cost times each room that he sweeps. Now let me show you something about the relationship between those two production possibility frontier equations, and this is what's interesting. Notice that the original equation was sweeping is equal to 6 minus 2 times scrubbing. Well, let's rewrite this equation and move scrubbing over to the left-hand side so that we have an equation that has scrubbing measured in terms of sweeping. Well, here's what I'll do. I'll move this minus 2 scrubbing to the left-hand side, and that's equal to 6 minus sweeping. So all I did was move this expression to the right-hand side and this expression to the left-hand side. Looks like I need to make sure that I change the sign when I move it over. Then let's divide both sides by 2, and I get scrubbing is equal to 3 minus 1/2 sweeping. There you have it. The production possibilities frontier can be written either way, in terms of sweeping or in terms of scrubbing. This is the vertical intercept, the maximum amount of scrubbing, and this, negative 1/2, is the opportunity cost. Here's one more interesting thing to note. Up here, this negative 2 was the opportunity cost of scrubbing measured in terms of sweeping. If Bernie wants to scrub a room, he gives up 2 rooms that he could have swept. Down here, this negative 1/2 is the opportunity cost of sweeping measured in terms of scrubbing. If Bernie wants to sweep a room, he gives up 1/2 of a room that he could have scrubbed. Now, this is the thing that's important to notice. The opportunity cost of scrubbing measured in terms of sweeping is the reciprocal of the opportunity cost of sweeping measured in terms of scrubbing. If Bernie wants to sweep a room, he has to give up half a room that he could scrub. If Bernie wants to scrub a room, he has to give up 2 rooms that he might otherwise sweep. See, the opportunity costs are reciprocals of each other, and that makes mathematical sense because whenever you're moving and dividing, you're going to wind up with the reciprocals. But it even makes good intuitive sense. It takes 10 minutes to sweep, it takes 20 minutes to scrub. So if you scrub, you're giving up 20 minutes divided by 10 minutes, 2 rooms you could have swept. If you want to sweep, that takes 10 minutes. So that means you're giving up 10 divided by 20 minutes, 1/2 of a room that you could have scrubbed. The opportunity cost of sweeping, measured in terms of scrubbing, is the reciprocal of the opportunity cost of scrubbing, measured in terms of sweeping. And that's really what it means to pick this diagram up and flip it around. You wind up with exactly the same line, only now you're measuring the axes differently. You're measuring the different variables on the different axes so that the intercepts are switched around. And the slope of the new line is the reciprocal of the slope of the original line. The original line with sweeping on the vertical had a slope of negative 2. The new line with scrubbing on the vertical has a slope of negative 1/2. Now, there's one more thing that we ought to notice about this picture before we begin to apply it to the bigger question of comparative advantage and gains from trade. That's this. Bernie's production possibilities curve is a straight line. What does that tell us about Bernie's technology, his abilities? Remember, the production possibilities frontier from our previous example with rice and wheat was bowed outwards. The outward bowed production possibilities frontier reminded us that not all resources are equally well suited to all uses. Some land is wet, it's good for rice. Some land is dry, it's good for wheat. Bernie, on the other hand, apparently has time and talent that's equally well suited to sweeping or scrubbing. There is no outward bow to Bernie's production possibilities frontier because there is no increasing opportunity cost. Anytime Bernie wants to sweep an extra room, it's going to take him 10 minutes. Anytime Bernie wants to scrub an extra room, it's going to take him 20 minutes. These are the assumptions that we've used to describe Bernie's technology. Well, because Bernie's costs are constant in this way, because all of his time and talent is equally well suited for sweeping and scrubbing, Bernie's opportunity cost is constant. The constant opportunity cost of 1/2 of a scrubbed room for every room that you want to sweep, or 2 swept rooms for every room that you want to scrub. This constant opportunity cost gives us a straight line production possibilities frontier. So, quick summary. A bowed outward production possibilities frontier, a concave production possibilities frontier, is for a case where the technology has increasing opportunity cost. And that's because not all resources are equally well suited to all uses. But a straight line production possibilities frontier is for a case where the opportunity cost is constant. And that will be the case when all resources are equally well suited to the production of either of the goods or services. So now we've given a thorough description of Bernie's technology. We started with his unit labor requirements. Then we looked at what he was able to do with 1 hour of his time. Then we looked at his schedule of all the possibilities of sweeping and scrubbing that Bernie can turn out. Then we drew a picture to represent his production possibilities, and we saw that it was a straight line representing constant opportunity costs. Then we showed that we could represent the production possibilities with either good on either axis. And what we found was that the opportunity cost of one in terms of the other was the reciprocal of the opportunity cost of the other in terms of the original good, -2 versus -1/2. Now, these are pretty technical points. In the next lesson, we're going to apply these technical points as we look at potential cooperation between Bernie and a business partner, Ann, as they seek to increase the wealth of their cleaning businesses. We've defined economics as the study of rational choice in situations of scarcity. In this lecture, we're going to take a closer look at the concept of scarcity and how economists describe scarcity. Scarcity means that you have a limited quantity of resources with which to satisfy potentially unlimited wants. But let's be more careful about that. What are those resources, and what can we do with them? How do we use our resources to create the goods and services that satisfy our desires? In order to represent the possibilities of an economy, we're going to introduce a tool, and that tool is the production possibilities curve. Now, we're going to be working towards that, but first, I want to introduce a concept that will be very important in this lecture and really throughout the course, and that's the concept of efficiency. Efficiency refers to doing the best you can with what you have, or making the largest quantity of output possible with your given quantity of inputs. Efficiency refers to getting the most you can out of what you have. So for instance, if we have a cook who is talented with lots of good recipes, and he has a lot of food in the kitchen to work with, and a good set of knives and other tools and a stove, efficient behavior would be using his talent and those resources to produce the most meals that he's capable of producing, getting the largest quantity of output from a given quantity of input. If he wastes some of the food, if he uses his time wastefully so that the quantity of output that goes out the door of his kitchen is less than is possible, then we say that his behavior is inefficient. Suppose we have an economy that produces 2 goods, and for the sake of our example, we'll make these an agricultural example. Our 2 goods are wheat and rice. So let's suppose we have an economy that produces these 2 products. Efficient behavior would be for the economy to produce the most wheat that it can possibly produce for a given quantity of rice. That is, using all of the resources that are left over that aren't producing rice and making the largest quantity of wheat possible. That's what we mean when we refer to efficiency, getting the most you can out of your limited quantity of resources. Now, I want to describe the production possibilities of a particular economy. This hypothetical economy produces only two goods, wheat and rice. Before I describe the production possibilities, you might want a little additional information. The first thing you're going to want to know is, well, what resources are available in this economy with which to produce these two grains? How much arable land is in this economy? Is the land wet or is it dry? What kind of labor is there in this economy? What kind of tools? Are there tractors and combines, or are there merely shovels and hoes? The first thing you need to know when you want to describe the production possibilities of an economy is, what is the resource endowment of that economy? How much land, labor, and capital does that economy have to work with? The second thing that you're going to want to know is, what are the capabilities of this economy given these resources? That is, what are the strategies this economy has for combining inputs to produce output? And we call that the economy's technology. When an economist refers to technology, the economist means a complete catalog of all the things this economy knows how to do, all the ways in which this economy can combine inputs to produce output. There are techniques that involve using shovels and hoes and low-skilled labor on particular kinds of land to produce rice or wheat. There are techniques that involve using tractors and combines and a different kind of land to produce rice and wheat. A technique is a particular combination of inputs, but a technology refers to all the possible combinations of resources that the economy can use to produce output. So when an economist refers to technology, the economist is referring to a catalog, a complete list of all the things the economy knows how to do. When your technology improves, it usually means that you're able to produce more output with less input because you're using that input in a smarter way. Now, given our knowledge of the economy's resources and what we know about the economy's technology, we're able to describe the production possibilities of the economy. And I'm going to do that first in this table. This table represents the production possibilities of our hypothetical economy. And every combination of numbers in this chart represents an efficient combination. That is, we're saying that if our economy uses its resources, all of them in the production of wheat, it can produce 80 bushels of wheat a year. Well, since all the resources are devoted to wheat production, there isn't going to be any rice production in this case. If the economy moves some of its resources into the production of rice, and let's suppose that it moves those resources that are best suited for rice production, the wet land, the workers who know more about rice production, tools that are well suited for the production of rice, the economy can produce 20 bushels of rice and still produce 78 bushels of wheat. Notice that the wheat production is decreasing as resources are moved into the production of rice. But since we're moving first those resources that are well suited for the production of rice, we can get a large increase in rice production for a small decrease in wheat production. Next, we can get an additional 20 bushels of rice per year if we reduce wheat production by 8 more bushels of wheat a year. The combination 70 and 40 is another efficient combination. That is, the maximum amount of wheat that we can get out of our economy when we're producing 40 bushels of rice is 70 bushels of wheat, if we're using all of the resources in the best uses possible and everyone is working as productively as they can. If we increase rice production to 60 bushels a year, wheat production falls to 55 bushels. And if we increase rice production to 80 bushels a year, then wheat production falls to 38. Finally, if we put all of the resources in our economy into the production of rice, we get 100 bushels of rice per year. And of course, no wheat, because all of the resources are devoted to rice production. So the production possibilities table represents those efficient combinations of rice and wheat production that are possible given the economy's technology and given its resource endowment. That is, for each number in the right-hand column, for each quantity of rice produced a year, the number in the left-hand column tells us the maximum quantity of wheat that this economy can produce, using its resources with efficiency. Now, I've got a production possibilities table here. I've got the combinations of wheat and rice that are possible to be produced in this economy. I'm going to now represent this information graphically. I'm going to put the production possibilities information into a diagram, and we're going to call this diagram the production possibilities curve, or the production possibilities frontier. First thing I need to do when I draw a diagram is make sure that I've carefully labeled the axes. So the first thing we'll do is we'll put wheat production on the vertical axis. That is, the number on the vertical axis refers to the quantity of wheat in bushels that's produced in this economy in a year. The next thing will be to label the horizontal axis, and we'll put rice production here. The number on the horizontal axis tells us the quantity of rice that's produced in this economy in a year. Now, next thing I want to do, since I'm going to be using real numbers and I want to be careful about plotting this curve accurately, I want to calibrate the axes. I'll want to put some numbers in that tell me how things are measured on each axis. Let's use, since I'm going up to 80 bushels of wheat, let's make each hash mark on this axis equal to 20. So here's 20 bushels of wheat. Here's 40. Here's 60. And here's 80. And I can keep on going, but I'm calibrating the axis here with each hash mark representing 20 additional bushels of wheat. Same thing with rice here. I'll make this be 20, and this 40, and this 60, and here's 80, and finally 1. And of course, it keeps going. Now I've got my axes calibrated and labeled carefully, so I'm ready to draw my graph. And let's now take the numbers, which are now over on the board, and put them as points on a curve in this diagram. So the first combination of wheat and rice that's possible is all the resources devoted to wheat production. We produce 80 bushels of wheat and 0 rice. That gives us a point that's right here on the vertical axis. The next combination is 20 bushels of rice and 78 bushels of wheat. So we go over here to 20 bushels of rice and up to 78 bushels of wheat, and I put another point on the curve. If we produce 40 bushels of rice, then the maximum wheat production I can get out of my economy is 70. So there's another point on the curve. With 60 bushels of rice, I get 55 bushels of wheat. With 80 bushels of rice, I get 38 bushels of wheat. And finally, with 100 bushels of rice, my wheat production has been pushed down to 0 because all of the resources are devoted to the production of rice. So what I did was take the numbers from the production possibility schedule and put them in a diagram with wheat on the vertical axis and rice on the horizontal axis. Now, these are not the only combinations of wheat and rice that we can imagine. In fact, you can imagine our economy moving resources continually or continuously out of the production of wheat into the production of rice, so that the quantity of rice produced increases gradually as the quantity of wheat produced falls gradually. If we plotted all the possible points, they would lie between these blue points, and if I connected the dots, I would get a nice, smooth, continuous curve. And this curve is called the production possibilities curve, or the production possibilities frontier. The production possibilities frontier is defined thusly. The production possibilities frontier is a collection of points representing the maximum amount of wheat that can be produced for a given quantity of rice production. These points are all of the efficient combinations of wheat and rice that can be produced in the economy. For any point on this horizontal axis, you can go up to the blue curve and find the maximum amount of wheat that can be produced when the economy is producing this quantity of rice. That's the production possibilities curve. As we look at the production possibilities curve, we can see that there are many things represented in this picture that are very basic concepts in economics. The first thing that we notice whenever we look at this picture is that there are points that are outside the production possibilities frontier. There are points such as this one, where we have 80 bushels of wheat and 80 bushels of rice produced in a given year. This point would be a great point because it involves a lot of everything. However, this point is not attainable. This point reminds us that scarcity is a reality in this economy. Given the quantity of land, labor, and capital, given our resource endowment, and given the technology that's available to us in this economy, this point out here, we'll call this point S because it represents scarcity. This point is unattainable. We simply can't get to it. There's no way to make this much wheat whenever we're making this much rice. So points that lie outside the production possibilities frontier represent a larger quantity of goods than this economy can possibly produce. They remind us of the reality of scarcity. Likewise, points that lie within the production possibilities frontier remind us of inefficiency. I'll call this point down here point U. Point U is certainly possible. It's always possible for us to produce points that are within the production possibilities frontier. But why would we want to? We would prefer to be up on the production possibilities frontier with more of everything. If more is better, we would always prefer a point on the blue curve to a point inside it. But these are the points that we wind up with when the economy uses its resources inefficiently. If the economy is not getting the maximum possible productive output from its resources, we're going to be inside this curve. That happens when some resources are unemployed, that is, if some of the land or labor is not used. It also happens if some of the resources are underemployed, that is, if resources are used in a way that is not maximizing their output. For instance, if we take wet land and use it to cultivate wheat, and dry land and use it to cultivate rice, we're going to wind up with less grain than we could produce. Because wet land is better for rice and dry land is better for wheat, we're going to wind up inside the production possibility frontier at a point of inefficiency, unemployment or underemployment of resources. Here's another thing to notice. The production possibilities curve is downward sloping. That means that as we increase production of rice, we are necessarily reducing the production of wheat. In order to produce additional bushels of rice, you have to give up wheat that you might otherwise have produced. That is, wheat is the opportunity cost of rice. Anytime you want to increase rice production, you're going to have to move resources out of the production of wheat. Land, labor, and capital that's used to produce wheat is transferred into the production of rice in order to increase rice production, and that means that wheat production will be decreasing. Wheat is the opportunity cost of rice. We can actually calculate this opportunity cost. Look, whenever we increase rice production from 0 to 20 bushels a year, wheat production is falling from 80 bushels to 78 bushels. The opportunity cost of the first 20 bushels of rice is 2 bushels of wheat. We can even calculate the opportunity cost per bushel of rice by doing a little calculation. First, let's calculate the change in wheat production. The change in wheat production is the new quantity of 78 minus the old quantity of 80 for a change in wheat production of -2, a loss of 2 bushels. The rice production is 20 minus the old quantity of 0, so the change in rice production is 20 bushels. 20 minus 0 equals 20. Now, divide the change in wheat production by the change in rice production, and you'll get -2 over 20, or -1/10. That is, for each additional bushel of rice that we are producing between 0 and 20, on average, we're giving up 1/10 of a bushel of wheat. 1/10 a bushel of wheat is the opportunity cost of each bushel of rice, on average, between 0 and 20. Notice something else, that if we draw a line connecting these 2 points, the original point of 80 and 0, and the new point of 78 bushels of wheat and 20 bushels of rice, if we draw a line connecting those 2 points, the slope of that line is going to be the change in wheat production divided by the change in rice production. Now remember, what's the formula for the slope of a line? The rise over the run. As we move between these 2 points, the rise is the change in wheat production. The rise is the change in the vertical coordinate. That is, we go from 80 to 78, -2. That's the rise. The run is the change in the horizontal coordinate. We go from 0 to 20. So that change of 20 is the run. -2 divided by 20 is the rise over the run. The change in wheat production divided by the change of rice production. And in this case, that number is -1/10. So I'll go ahead and put a little mark here indicating that I'm calculating the slope between those 2 points, and I'll make a note that it's -1/10. The slope of the production possibility frontier represents the opportunity cost of rice production, measured in terms of the wheat that we're giving up. As we move between these 2 points, each additional bushel of rice that we produce is costing us 1/10 of a bushel of wheat on average. The slope of the production possibility frontier is the opportunity cost of rice production, measured in terms of wheat given up. We can calculate the slope down here as we move from 80 to 100 bushels of rice, and we'll find we get a different number. The change in wheat production is the movement from 38 bushels of wheat to 0 bushels of wheat. Take the new quantity of wheat, which is 0, subtract the old quantity, which is 38, and you get -38, a loss of 38 bushels of wheat. The change in rice production is 100, the new quantity, minus 80, the old quantity. That gives us 20 bushels of rice added. -38 divided by 20 reduces to -19 over 10, or -1.9. If I connect these 2 dots, the slope of this dotted black line is the rise over the run, the change in wheat production divided by the change in rice production. And this slope in this case is -19 over 10, or -1.9. That is, for each additional bushel of rice that we're adding between 8 and 100, on average, we're giving up almost 2 bushels of wheat for each additional bushel of rice. The opportunity cost is 1.9 bushels of wheat lost for every bushel of rice added. Notice the opportunity cost down here is much larger. Each additional bushel of rice costs almost 2 bushels of wheat. Up here, each additional bushel of rice costs only 1/10 of a bushel of wheat. The opportunity cost is changing as we move along the production possibility frontier. And you can tell by looking at it. The slope of the curve is pretty flat up here near the vertical axis. As we move down the curve, the slope gets steeper and steeper and steeper and steeper as we approach the horizontal axis. Remember, the slope of the production possibility frontier is the opportunity cost of producing rice, measured in terms of wheat that you give up. So down here, the opportunity cost is very high, whereas up here, the opportunity cost is relatively low. What does that tell us? Well, this is the final thing to notice about the production possibility frontier, is that the production possibility frontier is concave. That is, it bows outwards. The slope of the production possibility frontier is pretty flat near the top and pretty steep near the bottom. And the slope is decreasing. That is, the slope is becoming a larger and larger negative number. The curve is getting steeper as we move down it. What does that tell us? It tells us that the opportunity cost of producing rice is increasing. The more rice we produce, the more expensive it gets to make another bushel. Why? That's because not all resources are equally well suited for the production of wheat and rice. Some resources are very well suited to the production of rice. These resources include wet land, workers who know a lot about rice cultivation, particular types of tools that are well suited for tending rice. Some resources are better suited to the production of wheat. Those include dry land. They also include workers who know a lot about wheat production, fertilizers that are good for wheat, and so forth. When an economy has a scarce, strictly limited quantity of resources, some of them will be very well suited to the production of one good. Others will be better suited to the production of the other good. In this case, when we first begin to produce rice, we're going to be using the wettest land and the workers that know the most about rice production. That wet land probably wasn't growing a lot of wheat. Therefore, when we first start to produce rice, we can do so with a small opportunity cost. Very little wheat is given up because that land wasn't very productive anyway for wheat. It was better suited for rice. But as we make more and more and more rice, we're using up all the land that's well suited for rice, and then eventually we have to draw on the land that's better suited for wheat, dry land, and workers who know more about wheat cultivation than they know about rice. That's when the opportunity cost starts to get very, very large. Down here, we have to move a lot of dry land out of the production of wheat just to get an additional 20 bushels of rice. And that's very costly in terms of the wheat that we lose. That's why the opportunity cost of rice production increases the more rice the economy chooses to produce. So, there you have it. 4 things about economics that you can tell by looking at a production possibilities frontier. First of all, you see that scarcity is a reality. Some combinations of wheat and rice are simply unattainable, given our technology and our resources. Next, notice that there are a lot of inefficient points. There are a lot of combinations of wheat and rice that aren't taking full advantage of the resources and technology that we have. Third, notice that the curve is downward sloping. That is, there's an opportunity cost. If you want to produce more rice, you have to give up wheat production. Once again, that's because of scarcity. And finally, the curve is concave. That is, the slope is getting steeper as we move down it. The curve gets steeper because the opportunity cost of rice production increases the more rice we make. This increasing opportunity cost is due to the fact that some resources are well suited to rice production and other resources are not. So this simple tool captures in it most of the basic ideas of economics: scarcity, efficiency, opportunity cost, the suitability of resources. In the next lesson, we'll look at how changes in resources and changes in technology affect the way this picture looks. Here's Bernie's, and remember these production possibilities diagram. Here's Bernie's, and here's Ann's. The slope of Bernie's production possibilities frontier is -1/2. That's the opportunity cost of sweeping measured in terms of lost scrubbing. Ann's opportunity cost is -1. That's her opportunity cost of sweeping in terms of lost scrubbing. Because sweeping is less expensive for Bernie, we had Bernie specialize in sweeping services. And we showed that we could get a large increase in total output if we had Bernie completely specialize in sweeping. So here's what we're going to have Bernie do. Rather than staying at sweeping 2 rooms and scrubbing 2 rooms, let's have Bernie completely specialize in sweeping, the task in which Bernie has a comparative advantage. So Bernie's production point now moves all the way to the end of the production possibilities frontier. Bernie completely specializes in sweeping. So here's Bernie's new output point right here. It's at the end of the production possibilities frontier where Bernie is now sweeping 6 rooms and scrubbing 0. We had Ann then specialize by moving up in this direction. Ann reduces her sweeping, taking advantage of Bernie's low-cost sweeping, and Ann scrubs instead. Ann moves her production point up to this dot on her production possibilities frontier. Ann winds up scrubbing 9 rooms and sweeping only 3 rooms. When she does that, she's able to take advantage of Bernie's low-cost sweeping and increase the total number of rooms that she cleans. Now, if you'll have a look over on the board, you'll see our totals with trade. With trade, Bernie sweeps a total of 6 rooms and scrubs 0. Ann sweeps a total of 3 rooms and scrubs 9. The total number of scrubbed rooms is 9 plus 0, or 9. The total number of swept rooms is 6 plus 3, or 9. Working together, Bernie and Ann are able to sweep and scrub a total of 9 rooms. Looking at this picture, how could we have known that Bernie was going to wind up specializing in sweeping services? Well, we would know because Bernie's production possibilities frontier is flatter than Ann's. His slope is -1/2, Ann's is -1. Because Bernie's production possibility curve has a flatter slope, we know that Bernie's opportunity cost is smaller for sweeping than Ann's is. Bernie has an opportunity cost of 1/2 room scrubbed. Ann has an opportunity cost of 1 whole room scrubbed. Therefore, Bernie will specialize in sweeping because he has a comparative advantage in sweeping. Ann will then specialize in scrubbing. Now, finding the exact numbers where this story worked out requires a little bit of puzzle solving. I had to figure out, well, if Bernie specializes, that's 6 rooms worth of sweeping, so Ann has to do at least 6 rooms worth of scrubbing, which leaves her 6 times 5 is 30 minutes from an hour. That leaves Ann 30 minutes or half an hour for additional work. And since 6 and 6 is already taken care of, then she would have to split that remaining time between sweeping and scrubbing. And that's how I wound up with her sweeping 3 rooms and scrubbing 3 additional rooms for a total of 9. So that took a little bit of puzzle thinking. I had to do a little logical problem solving to get the actual numbers. The things you should learn from looking at the diagrams are as follows. First, the trader that has a flatter production possibilities frontier will have a comparative advantage in providing the good or service that is written on the horizontal axis. Here, Bernie has a comparative advantage in providing sweeping services because his opportunity cost is lower in terms of scrubbing than Ann's opportunity cost. The next thing to notice is that if you have a comparative advantage in one good, you have a comparative disadvantage in the other good. Bernie has an opportunity cost of 2 rooms worth of sweeping for every room of scrubbing he does. Ann can scrub a room by only giving up 1 room worth of sweeping. Because these slopes are reciprocals, if you have a comparative advantage in one good, you have a comparative disadvantage in providing the other good. Just as Bernie has a relatively low opportunity cost for sweeping, he has a higher opportunity cost than Ann for scrubbing. All right, so you've always got a comparative advantage in something. Even though Ann can sweep and scrub faster than Bernie, Bernie is relatively better at sweeping than he is at scrubbing. And therefore his opportunity cost is lower, and that's why he and Ann can get together and make a deal that benefits both of them. It's not driven by absolute advantage. The story is driven by comparative advantage. And no matter how unproductive you are, you always have a comparative advantage in something. Even though Bernie has higher costs for providing all services and Ann can do everything faster, Bernie is still relatively less unproductive at sweeping than he is at scrubbing. And that's how he and Ann can get together and make a profit. The last thing to notice is that by getting together and trading, Bernie is able to make a deal that's satisfying to him. Before he was sweeping 2 rooms and scrubbing 2 rooms. Now that he's completely specialized in sweeping services, he would be willing to trade as many as 4 rooms worth of sweeping to get 2 rooms worth of scrubbing in exchange. That would put him right back where he was before. And Ann is happy to give him 2 rooms worth of scrubbing because that would leave her ahead of where she was before. So once Bernie specializes according to his comparative advantage, there's room for him and Ann to work out a deal that makes one or both of them better off. That's the magic of comparative advantage. By people specializing according to comparative advantage, everyone who's trading can gain. In the next example, we'll use a story that sounds a little bit more like the international trade stories you read in the newspaper. We'll look at 2 countries that are producing 2 agricultural products and show that by specializing in trading, they can both be made better off. In the last lesson, we introduced the Production Possibilities Frontier, a tool that describes what an economy can produce, given its resources and its technology. In this lesson, we're going to take a dynamic look at production possibilities. We'll ask, what happens to the productive capacity of an economy when there's some kind of change in its environment? Perhaps its resources increase or decrease. Perhaps technology changes in some particular way. What then happens to the combination of goods and services that that economy can produce? Let's take another look at the Production Possibilities Frontier. Remember, it's a downward sloping line representing the fact that if you want to produce more rice, you've got to produce less wheat. The movement of resources from the production of one good to the other is necessary and creates a kind of opportunity cost. That is, the opportunity cost of increasing rice production is reduced wheat production. We draw this line when we know the economy's resource endowment and its technological possibilities. That is, what the economy is capable of doing with the resources that it has. Suppose now we change one of those constraints. Suppose we change the technological possibilities in the economy, or suppose we change the resource endowments. In that case, the production possibilities curve will shift. A movement along the production possibilities frontier represents a change in the economy's choice of which combination of goods to produce. If an economy decides that it wants to produce a lot of wheat and a little rice, it will be at a point on the production possibilities frontier up here. If the economy wants to produce a lot of rice and a little wheat, they'll be down at a point like this. If the economy wants a balanced output of wheat and rice, they'll be at a point like this. Whenever the economy changes the combination of wheat and rice that it produces, it moves along the existing production possibilities curve. Suppose now that we change one of those things that we hold constant when we draw the curve. Suppose we change resources or technology. Anytime you change something that was held constant when you drew the curve, you have to redraw the curve. Anytime you change a variable that's not represented on one of the axes, well, you've got to redraw the curve to represent new production possibilities. Let's start and suppose that we have general technological progress in the economy. Suppose there's an agricultural revolution, and this economy discovers new and more productive ways to make both rice and wheat with their given resources. In that case, the production possibilities curve will shift outwards. The curve shifts outwards, representing the fact that after technical progress, it's now possible to produce more wheat for a given amount of rice than before. Before, when we were producing 20 bushels of rice, we could only produce 78 bushels of wheat. Now, after technological progress, we're able to produce maybe as many as 85 or 90 bushels of wheat when we produce 20 bushels of rice. For every quantity of rice produced, we can now make more wheat than before. For every quantity of wheat produced, we can now make more rice than before. Technical progress allows us to expand our production possibilities. We can now make more than before with our given quantity of scarce resources. Suppose now that we have general migration of labor into the economy, and that this labor is well suited for either working in the production of rice or wheat. A migration into the economy of agricultural labor would also shift the production possibilities curve outwards. Now, with more workers to employ in the production of wheat and rice, we can make more wheat and rice than before. For any quantity of rice we produce, we can now produce a larger quantity of wheat than before. For any quantity of wheat that we produce, we can now produce a larger quantity of rice than before. An increase in labor allows us to expand our production possibilities in this economy. Suppose now that we have a different kind of change. Let's suppose that a change occurs that increases this economy's productivity in the wheat industry, but not in the rice industry. Suppose a new fertilizer is discovered that increases the productivity of wheat farms, but doesn't do anything for rice farms. How would we show that change in this picture? production possibilities would change in such a way that there would be an increase in wheat production, but no change in potential rice production. That is, if the economy continued to devote all of its resources to the production of rice, it would only be able to produce 100 bushels of rice, just like before. But if the economy devoted all of its resources to the production of wheat, they might be able to produce 120 bushels of wheat with this new fertilizer. The new fertilizer increases the productivity of wheat without changing the productivity of rice. So we get a skewed shift in the production possibilities curve, one that is slanted in the direction of increased wheat production without changing the productivity of rice. Let's consider another possibility. Suppose the climate of our economy changes. And with this change in climate in our economy, let's suppose that the ground is wetter most of the year. It rains more often, the ground gets soaked and saturated. What's that going to do to the productivity of our economy? What's that going to do to our production possibilities? Well, let's suppose that this extra wetness hurts the production of wheat and helps the production of rice. We would then show the shift in the production possibilities curve looking something like this. The amount of rice that could be produced with this increased wetness would be larger, maybe up to 120 bushels of rice a year. The amount of wheat that could be produced would shrink, maybe down to 60 bushels a year. With this change in the climate, there is a reduction in the productivity of this economy for making wheat and an increase in its productivity in making rice. One final thing, let's suppose we have a large out-migration of labor, that a lot of people leave this economy to go to work somewhere else. Or suppose an earthquake occurs and wipes out a lot of the capital stock, a lot of the tools and equipment that are used. In that case, the production possibilities frontier would actually shift inwards. There would be a reduction in the productivity of this economy. It could produce less of everything. So that producing 20 bushels of rice might leave you only enough resources to make, say, 55 bushels of wheat instead of the previous 78. So it's possible sometimes that the production possibilities curve would actually shift inwards, representing a reduction in the economy's productivity. So, a quick summary then. Things that increase the productivity of the economy, an increase in the stock of resources, an improvement in technology, those things shift the production possibilities curve outwards. Those things that reduce productivity, such as a loss of labor or capital or an unfavorable change in the climate, shift the production possibilities curve inwards. And sometimes changes in the economy will affect the two different sectors in different ways. They might actually cause one sector to become more productive and the other sector to become less productive. I'd like to end with a question. And this is a question that came up during your quiz in the last lecture. Look at this production possibilities curve. Of all of these choices, which is the one that our economy prefers? Which combination of wheat and rice is going to make consumers the happiest? The answer is, we have no idea. There's no representation in this picture for consumer preferences. Unless you know something about consumer preferences, you're not able to say which of these feasible points is the most desirable. If our economy likes a lot of wheat, this point up here might be the best one. If our economy likes a lot of rice, this point might be the best one. If our economy likes a nice balanced mixed, then this point might be the best one. The point I'm trying to make is this. The production possibilities curve tells you about the supply side of an economy. It tells you about what this economy is able to produce, given its limited quantity of resources, given the technical know-how that the economy possesses, given the peculiarities of the resources, some being well suited for the production of wheat, some being well suited for the production of rice. But this diagram tells you nothing about which of the points is the most desirable. In order to tell which of these points is best, we would have to bring in something from the demand side of the economy, knowledge about what pleases consumers. So the blue line here is purely a statement about engineering, what our economy is able to make. And the important concept from this lesson is the concept of efficiency, doing the best you can with the resources that you have and the know-how that you possess. That is, each point on the blue curve is efficient because it represents the maximum amount of wheat that our economy can produce when it produces a given quantity of rice. The blue line represents doing the best we can with what we have, and that's the definition of efficiency. In this lesson, we're going to introduce the concept of comparative advantage and show how two people with different abilities can cooperate to increase their wealth. In the last lesson, we introduced Bernie and his cleaning service, and we discussed his productivity and his production possibilities. In this lesson, we're going to introduce a partner for Bernie. Her name is Anne, and she has her own cleaning service. We're going to find out that because of their different abilities, Bernie and Anne can form a joint venture and, in fact, do a lot more cleaning together than they can do separately. Let's begin by looking at Anne's productivity. Let's suppose that Anne has the following unit labor requirements. Anne is able to scrub a room in 5 minutes, and Anne can sweep a room in 5 minutes. The first thing you notice looking at this chart is that Anne is able to sweep and scrub faster than Bernie. We say that Anne has an absolute advantage in the provision of both services. Whenever you can do something with less effort or fewer resources than another person, you have an absolute advantage in the provision of that service. Because Anne can scrub faster, she has an absolute advantage in scrubbing. Because Anne can sweep faster, Anne has an absolute advantage in sweeping. Now, let's suppose Anne spends an hour doing sweeping or scrubbing. What is the maximum output that she could expect? Well, divide 60 minutes, 1 hour, by 5 minutes that it takes to scrub a room, and you get that Anne's maximum number of rooms scrubbed in 1 hour is 60 divided by 5, or 12. Likewise, if Anne wants to sweep for an hour, she can sweep a total of 60 minutes divided by 5 minutes per room swept to get a total of 12 rooms swept. So with Anne's unit labor requirements here and 1 hour's worth of time to work, Anne's maximum output would be given by this table. Just as Bernie can scrub a maximum of 3 rooms or sweep a maximum of 6 rooms, Anne can scrub a maximum of 12 rooms in an hour or sweep a maximum of 12 rooms in 1 hour. We can now take this information and look at Anne's production possibilities schedule. With 1 hour's worth of time, if Anne wants to divide her time between sweeping and scrubbing, what possible combinations of output can she get? Well, let's have a look. Here's a table then that represents Anne's possible output, sweeping and scrubbing. If Anne spends all of her time scrubbing, she can scrub 12 rooms. That means she does no sweeping. If she wants to sweep 2 rooms, that's going to take her 2 times 5 minutes per room for a total of 10 minutes. Subtract 10 minutes from 60 minutes, and that leaves 50 minutes. 50 minutes divided by 5 is 10 rooms worth of scrubbing that Anne can do. 50 minutes is long enough for Anne to scrub 10 rooms at 5 minutes per room. And so forth. The opportunity cost for Anne of sweeping another 2 rooms to bring her to a total of 4 would be a loss of 2 rooms worth of scrubbing. Should be down to 8 rooms scrubbed. 6 minutes would be, or 6 rooms of sweeping would be 6 times 5 minutes, or 30 minutes spent sweeping, leaving her a half an hour for scrubbing. Divided by 5 minutes is a total of 6 rooms scrubbed. Notice that all of these numbers in this column, 12 and 0, 10 and 2, 8 and 4, and so forth, all of the combinations add to a total of 12. That's because Anne's opportunity costs are 1 room swept for 1 room scrubbed. How did I calculate that? Well, the cost of sweeping a room is 5 minutes of Anne's time, divided by 5 minutes that it takes to scrub a room. That means every room that Anne sweeps is a room she's not scrubbing. Her opportunity cost is constant. The opportunity cost of sweeping 1 room for Anne is 1 room worth of lost scrubbing. Likewise, because of this reciprocal principle, if Ann scrubs a room, that's a room that she's not sweeping. She spends 5 minutes scrubbing, that's the same 5 minutes she could be spending sweeping. So the opportunity cost of 1 room worth of scrubbing is 1 room worth of lost sweeping. Here's Ann's production possibilities schedule. Now, let's convert this production possibilities schedule into a production possibilities curve. Let's draw a diagram like the diagram that we drew for Bernie. I'll clear my pad here, and I'll move these numbers over onto the board so that you can use them for reference. Well, over here I've got Bernie's production possibilities frontier that we drew in the last set of lectures. And to remind us about Bernie's situation, we'll go ahead and put up his equation. Bernie's production possibility frontier is described by the following expression. The total number of rooms that Bernie can scrub is equal to 3, that is if he spends a whole hour scrubbing, minus 1/2 the opportunity cost times the number of rooms that he sweeps. Each room that he sweeps is 10 minutes, and that means that he's giving up 20 minutes divided into 10, or 10 divided by 20, or 1/2 of a room worth of scrubbing. We saw this last time. Every room that he sweeps is 10 minutes worth of time, and that's half of a 20-minute job worth of scrubbing that he's not able to do. The intercept tells you the maximum amount of scrubbing that Bernie can do, and the slope of the line tells you the opportunity cost of a room swept, measured in terms of lost scrubbing. So here's Bernie's equation, and here's his production possibilities curve. Now we can draw the curve for Ann. Well, let's start. If Ann does no sweeping and all scrubbing, then she can scrub 12 rooms. So let's put a dot here in her curve that represents 12 rooms worth of scrubbing and 0 rooms worth of sweeping. If she decides that she wants to do a little bit of sweeping, every time she wants to sweep an additional room, she has to give up a room worth of scrubbing. So that gives us combinations like 10 and 2 and 8 and 4 and so forth. And we get these points all the way down the curve. Every time Ann decides that she wants to sweep an extra room, she loses a room worth of scrubbing, until finally we get down to this horizontal axis where she's sweeping 12 rooms and scrubbing 0 rooms. Notice we can connect the dots here to find Ann's production possibilities frontier. So let's connect the dots. And just like Bernie, Ann's production possibilities frontier is a straight line. What does that tell you? What does it tell you that Ann has a straight line production possibilities frontier? It tells you that her opportunity cost is constant. Anytime she wants to sweep an extra room, she gives up 1 room worth of scrubbing. Why is her opportunity cost constant? It's constant because her time and resources are equally well suited to providing each of the 2 services. Ann would just as soon scrub a room as sweep a room. She can just as easily, with her time and talent, do either. There is no change in opportunity cost. If Ann does more sweeping, she always does so by giving up 1 scrubbed room for each additional room she sweeps. Her opportunity cost is constant. Let's look at the curve here and see what we find. The vertical intercept of Ann's curve is going to be 12. That's the maximum amount of scrubbing that Ann can do. Down here, the horizontal intercept is also going to be 12. That's the maximum amount of sweeping that Ann can do with an hour's worth of time. The slope of the production possibilities curve is rise over run, or -1. That is, every additional room that Ann sweeps is 1 room worth of scrubbing that she no longer has time to do. You find the opportunity cost by dividing the number of minutes that it takes to sweep by the number of minutes that it takes to scrub. 5 minutes worth of sweeping divided by 5 minutes worth of scrubbing gives you the opportunity cost of sweeping measured in terms of scrubbing that Ann is not able to do. Every time she sweeps a room, that's a room worth of scrubbing that she gives up. The slope of the curve is -1. Now, one more thing to do before we start talking about comparative advantage. And that is, suppose Bernie and Ann were working independently of one another. What kind of outcome could they expect? Well, here's Ann's production possibilities frontier. The formula is the amount of scrubbing she can do is equal to 12 rooms worth of scrubbing minus the number of rooms that she sweeps. The coefficient on sweeping is 1, -1. That's the cost to Ann to sweep a room. It's 1 room worth of lost scrubbing. Here's Bernie over here, and we know that his production possibilities are represented by this equation. Let's suppose that Bernie and Ann are both running cleaning businesses and that they are working independently of each other. If Bernie and Ann work independently of each other and don't cooperate, then let's suppose that each of them has to sweep the same number of rooms that they scrub. You go to a house and it's got 2 rooms in it. You've got to sweep each room and you have to scrub each room in order to clean that house. So the question is, if Bernie and Ann have to sweep and scrub the same number of rooms each, that is, Bernie has to sweep, say, 2 rooms and scrub 2 rooms, and Ann has to, say, sweep 6 rooms and scrub 6 rooms, well, what numbers are going to work out? What's the maximum number of rooms that Bernie can clean by himself? What's the maximum number of rooms that Ann can clean by herself? Remember, the numbers have to be equal for sweeping and scrubbing for Bernie, and the numbers have to be equal for sweeping and scrubbing for Ann. Well, the numbers that work for Bernie, as it turns out, are 2 rooms. Bernie can sweep 2 rooms, and that takes him 2 times 10 minutes each for a total of 20 minutes worth of sweeping. That leaves him 40 minutes for scrubbing, and since it takes him 20 minutes to scrub a room, 40 minutes divided by 20 means that he has time left to scrub the 2 rooms. So if Bernie works by himself, then he is able to sweep and scrub 2 rooms each. So it looks like that point would be right here on the diagram. Bernie working by himself winds up scrubbing 2 rooms and sweeping 2 rooms. If Ann works by herself and she sweeps 6 rooms, that's going to take her 6 times 5 minutes each is 30 minutes, leaving her half an hour for scrubbing. Since it takes her 5 minutes to scrub a room, she can also scrub the 6 rooms. So Ann working by herself is going to be able to sweep 6 rooms and scrub 6 rooms. Now, if you look over on the board, I'm going to do a summary of this outcome. When they work independently of each other, and each one of them has to sweep and scrub the same number of rooms, then Bernie is able to sweep and scrub 2 rooms in an hour, Ann is able to sweep and scrub 6 rooms in an hour. Here's what you'll notice over on the board. I've done a table of what Bernie and Ann are able to produce when they are not cooperating. When they work independently, Bernie scrubs 2 rooms, Ann scrubs 6 rooms for a total of 8 rooms worth of scrubbing. Whenever they work independently, Bernie can sweep 2 rooms, Ann can sweep 6 rooms for a total of 8 rooms of sweeping. 8 total rooms get cleaned when Bernie and Ann work independently of each other. Next, I'm going to show how Bernie and Ann can increase the profits of their business. That is, how Bernie and Ann can cooperate and clean more rooms together than they can when they work independently. And this is where we come to the concept of comparative advantage. Here we have Bernie, and here we have Ann. And next to each of our players, we have their present production pattern. Bernie is sweeping 2 rooms and scrubbing 2 rooms. Ann is sweeping 6 rooms and scrubbing 6 rooms. Now, we're ready to introduce the concept of comparative advantage. Comparative advantage refers to your opportunity cost relative to the opportunity cost of someone with whom you might trade. We say that you have a comparative advantage in the provision of a particular good or service if your opportunity cost of providing that good or service is lower than the opportunity cost of someone with whom you might trade. Let's use an example now to try to make this concept very clear. We'll start by looking at the opportunity costs of our 2 players and look at who has a lower opportunity cost for providing the service of scrubbing. Let's start with Bernie. If Bernie scrubs a room, it takes him 20 minutes. Now, since it only takes him 10 minutes to sweep a room, Bernie's opportunity cost for scrubbing 1 room is 2 rooms worth of sweeping that he's not doing. So that's his opportunity cost. Now, you can also express this by dividing both sides by 2. His opportunity cost of sweeping one room is half a room that he doesn't then have time to scrub. So the opportunity cost for Bernie of scrubbing one room is 2 rooms worth of sweeping that he doesn't do. Let's look now at Ann's opportunity cost for scrubbing. Ann takes 5 minutes to sweep a room and also 5 minutes to scrub a room. So the opportunity cost for Ann of scrubbing a room is 5 minutes worth of time, which means sweeping one room. So if Ann scrubs a room, it's because she's not sweeping a room. Her opportunity cost of scrubbing one room is one room that goes unswept. Given this information, we know who has a comparative advantage in scrubbing. For Bernie, scrubbing costs 2 rooms worth of sweeping. For Ann, scrubbing costs only 1 room worth of sweeping. Ann has a lower opportunity cost for scrubbing, and therefore Ann has a comparative advantage in providing scrubbing services. Well, why should you care? Why should you care that Ann has a comparative advantage? Because comparative advantage is a guide to how Bernie and Ann can specialize and therefore increase their wealth. By specializing in trading, Bernie and Ann can clean more rooms than they can working independently. Let me show you how this works. Let's suppose Bernie decides to reallocate his time and specialize in sweeping, that is, to do more sweeping and less scrubbing. Why am I having Bernie do more sweeping and less scrubbing? Because scrubbing is relatively expensive for Bernie to do. He doesn't have a comparative advantage in scrubbing. He would like to work out a deal where Ann does more scrubbing because her cost is lower. Bernie will do more sweeping because his cost for sweeping is lower. Remember, when Bernie sweeps a room, he only gives up half a room worth of scrubbing. Ann gives up a whole room worth of scrubbing. So Bernie has a comparative advantage in sweeping, just as Ann has a comparative advantage in scrubbing. So let's have Bernie specialize according to his comparative advantage and see what happens. Well, first thing that happens is Bernie reallocates 20 minutes of time away from scrubbing and instead winds up sweeping 2 additional rooms. So with his newly allocated time, Bernie adds 2 rooms worth of sweeping and loses 1 room worth of scrubbing. Well, now he's sweeping 4 rooms and scrubbing 1. So he needs a little bit of help here from Ann in order to make sure that he's getting a full house cleaned. What he does then is he offers to trade with Ann 2 rooms worth of sweeping, those newly created 2 rooms, and see if Ann will give him some scrubbing in exchange. So what Bernie does then is give some sweeping services to Ann. He sweeps 2 rooms for her. Well, this now frees Ann not to have to sweep those 2 rooms herself. And with those rooms not having to be swept by Ann, she has 5 minutes here and 5 minutes here that she can now reallocate towards scrubbing. So Ann sweeps less and scrubs more. She moves this time into scrubbing and increases her scrubbing activity as she cuts back on her sweeping. So now Ann is sweeping 4 rooms, plus she's getting 2 rooms worth of sweeping services from Bernie, and that allows her time to scrub a total of 8 rooms. She can now give one of those scrubbed rooms to Bernie, that is, scrubbed one of his rooms, and he's just as well off as he was before. Now with this help from Ann, Bernie has 2 rooms scrubbed and 2 rooms swept. He's also sweeping 2 rooms from Ann, so she can scrub 2 additional rooms. And if you look, our total output now is 8 rooms worth of sweeping and 9 rooms worth of scrubbing. Where did this extra room of scrubbing come from? It came from specialization. Because Bernie specialized according to his comparative advantage, these 2 working together were able to scrub an additional room. They were able to turn out a little bit of extra labor relative to what they did before. So now Bernie and Ann have 8 rooms swept and 9 rooms scrubbed. Can they do any better? Well, probably so. Right now we've got an unequal number of sweeping and scrubbing, so we've got this scrubbed room that's unswept. Let's see if we can do any better. Well, of course we can, and what should we do? We should have Bernie do even less scrubbing. That is, here's the room that Bernie's still scrubbing. Let's have him take those 20 minutes and sweep instead. That way he can turn out 2 more rooms worth of sweeping services. This promises to be a good deal. Now Bernie is doing no scrubbing at all. He's doing all sweeping. He's got 1 room worth of scrubbing services from Ann that he's acquired, and now he's ready to give Ann 2 more rooms worth of sweeping. Once he gives her those 2 more rooms, Ann is now freed to scrub some more. She converts her time from sweeping away to scrubbing, and now we've got all these scrubbed rooms that Ann has done, and she can send one of them over to Bernie. Bernie's just as happy as he was before. He's got 2 rooms swept, 2 rooms scrubbed. Ann is scrubbing both of these rooms for him, and he is sweeping these 2 rooms plus 4 more rooms from Ann. But the total now that we've got here is 1, 2, 3, 4, 5, 6, 7, 8 rooms swept, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 rooms scrubbed. Well, we've got a little bit of an imbalance here, and the imbalance is that we've got more rooms scrubbed than we have swept. If Ann wants to be able to sweep and scrub equal numbers of rooms, then she might want to convert one of these scrubbings back into a sweeping so that she now has equal numbers of rooms swept and scrubbed. Well, look at this. Ann has now got a total of 1, 2, 3, 4, 5, 6, 7 rooms swept, 1, 2, 3, 4, 5, 6, 7 rooms scrubbed. Bernie has 2 rooms swept and 2 rooms scrubbed. By cooperating and specializing according to comparative advantage, by Ann doing more scrubbing and Bernie doing more sweeping, and by trading with each other, Bernie is just as well off as he was before, and Ann is better off than she was before. Now, is that necessarily going to be the case? Well, not necessarily. I mean, certainly since we have 9 rooms clean now instead of 8 before, the 2 of them combined are able to make more money with their cleaning business. Ann could stay where she was before and leave Bernie with 3 rooms clean, and Ann would still have the same 6 rooms swept and scrubbed as before. It doesn't really matter who gets the benefit. That will be determined by which of these 2 is a more persuasive bargainer. But the point that I want to make is this. By Bernie specializing according to his comparative advantage, and by Ann specializing according to her comparative advantage, the 2 of them working together, specializing and trading, are able to produce 9 clean rooms, 9 swept, 9 scrubbed rooms, rather than simply 8 as before. Now, let's take a look at the production possibilities frontier and show how this story translates into a graph.